Imagine a world where the boundaries between the human mind and machines blur, creating a seamless integration that enhances our cognitive abilities, connects us in unprecedented ways, and even allows us to transcend the limitations of our biological bodies. This isn't a scene from a sci-fi movie. It's the horizon of human-machine symbiosis and mind uploading. With companies like Neuralink leading the charge, we're stepping into an era where these concepts are not just possible, but are becoming reality. Today we'll explore the evolution of human-machine interactions, the groundbreaking technology of Neuralink, the science and ethics of mind uploading, and what the future might hold for us in this brave new world. The concept of human-machine symbiosis isn't new. It's been a topic of discussion and research since the 1960s, with visionaries like J.C.R. Licklider imagining a future where humans and computers would work together in a symbiotic relationship, enhancing each other's capabilities. Fast forward to today, and we see this vision coming to life in various forms, from advanced prosthetics that mimic natural limb movements to brain-computer interfaces, BCIs, that allow users to control devices with their thoughts. These technologies are not just extensions of the human body, but are becoming integral parts of our identity, reshaping our interactions with the world around us. As the lines between human and machine continue to blur through integrated implants, robotic limbs, and neural implants, we are transforming into cybernetic organisms, cyborgs, that transcend the capabilities of our biological selves. Neuralink, founded by Elon Musk, is at the forefront of developing BCIs with the potential to revolutionize how we interact with technology. Their device, equipped with 1,024 electrodes, can pick up signals from a vast number of neurons, offering unprecedented bandwidth for human-computer communication. This technology promises to restore independence to those with unmet medical needs by enabling fast and reliable computer control. But Neuralink's ambitions go beyond medical applications, aiming for a future where BCIs enhance cognitive abilities, sensory experiences, and even allow for direct communication between minds. In the short term, Neuralink aims to develop implantable devices that enable paraplegics to operate computers and mobile devices using just their thoughts. But the long-term vision is far more profound. A future where BCIs integrate us seamlessly with artificial intelligence, significantly augmenting mental capabilities. Through bidirectional communication between brains and machines, these implants could not only restore motor functions, but accelerate learning, improve memory retention, augment sensory experiences, and provide a platform for merging minds across vast distances, enabling a hive mind of shared thoughts and experiences. Mind uploading, the hypothetical process of transferring a person's consciousness into a digital format, raises profound questions about human consciousness and identity. While the technology to achieve mind uploading is still speculative, its implications are worth considering. It challenges our understanding of what it means to be human, and raises ethical concerns about identity, privacy, and the potential for digital immortality. The science behind mind uploading relies on the concept that human consciousness emerges from the computational activities of the brain. Just as software can be transferred from one computer to another, proponents argue that mappings of neural impulses in the brain could potentially be uploaded to a computer system that would replicate that individual's personality, behaviors, knowledge base, and experiences. This mind clone, or whole brain emulation, could then reside in a computer where it might enjoy digital immortality, capable of interacting through virtual environments, or even robotic bodies integrated with sensors. However, there are significant barriers still facing the realization of mind uploading technology. We still lack a full understanding of how consciousness arises in the brain, and enormous computational power would be required to create high-fidelity brain simulations that capture the complexity of 100 billion neurons with 100 trillion synaptic connections. So while future advancements in brain mapping and computing could make whole brain emulation more feasible, currently it remains on the speculative fringes of neuroscience. And even if technologically possible, there are pressing ethical issues to grapple with concerning identity, privacy, personhood of uploads, and resource allocation between biological and digital populations. It also faces skepticism from neuroscientists, philosophers, and computer engineers who argue that a digitized version of the self is still fundamentally different from the original. Imagine a future where mind uploading is possible. This could change everything from how we learn and communicate to how we perceive existence itself. Visual aids and animations can help us grasp what this process might look like, depicting the transfer of consciousness from the biological brain to a digital medium. The process would likely involve nanobots with very high-resolution scanning abilities to map the complex web of neural connections that encode memories, personality traits, and behavioral patterns. As these tiny robotic scanners capture the intricacies of neuronal pathways, pulsating with dynamic electrical signals, their readings would feed into an elaborate supercomputer capable of modeling biological brains. Once fully mapped in digital form, this virtual brain, powered by advanced AI algorithms, could mimic the complex neural oscillations underpinning the individual's consciousness. Perhaps sensors, cameras, and microphones embedded in a robotic body could provide inputs and outputs to facilitate interaction with the physical world. As artificial eyes register visual stimuli and artificial ears receive auditory signals, the virtual mind processes this data, forming perceptions, thoughts, and sensations subjectively akin to those of the original biological entity. In this way, it would be as though awareness emerged into a new substrate, digitally dreaming within dataspheres as vast swirling fractals of code spark into consciousness. Perhaps multiple instances of these uploaded minds could populate online worlds, exploring new virtual frontiers or competing and collaborating towards shared goals. They may traverse alien geographies as streams of pure data reflected onto robotic avatars for brief glimpses of physicality. Or they may direct orbits of drones and satellites by thoughts alone, enjoying omniscience and omnipresence without a localized body. As we stand on the brink of these technological advancements, it's clear that the future of human-machine symbiosis and mind uploading holds both incredible promise and profound challenges. From enhancing human capabilities to redefining our very essence, the journey ahead is as exciting as it is uncertain.